In the last section of the course, we learned several algorithms for working with arrays, and during those tutorials, we've seen how it was rather difficult in some instances to manipulate an array, such as deleting an element. We saw that once you create an array, you can't grow or shrink the size of the array, nor can you actually delete from the array. What we did instead was overwrote the element that we wanted to delete, then we copied the contents of our array into a new, shorter array. So this is where other data structures come into play. It's important that we have a data structure which can perform tasks like deleting elements, or deleting an element from a specific spot in the data structure, or inserting a new element into a specific spot in the data structure. To accomplish these types of tasks, Java gives us the linked list data structure. This data structure provides very efficient methods to insert and remove elements from anywhere within the list, unlike arrays. Now, linked lists make this type of data structure manipulation and traversal easy and efficient through the use of nodes. So each element in the list is going to have a node which points to the next element within the list. Let's switch into Eclipse and practice working with linked lists. I'm going to create a new class. I'll name it linked lists. That's with a capital L for linked and a capital L for lists. I'm going to stick this into my Intro to CS package, and then into the data structures package, and make sure to check the checkbox here to create your main method, and we'll hit finish. Now, to use linked lists, we first need to import the class at the top of our file. So let's use the import keyword, and that's inside of the Java and util packages, and it's named linked list with a capital L for linked and a capital L for list. Next, inside of our main method, I'm just going to change this comment to say working with linked lists. All right, now let's create a grocery list of some food that we might need to pick up at the grocery store. So to create a linked list, it works very similar to creating an array list. We use the class name, linked list, and then inside of angle brackets, we specify the type of data that the list will be holding. So this is just going to be holding a list of strings. So I'll put the data type as string. And then we just need to give it a name. I'm going to name it glist, short for grocery list. And we'll just create a new linked list here. And then again, inside of angle brackets, we put our type of string. We open up our parentheses, and we end the statement with a semicolon. And that creates our glist linked list. Now, to add data into the list, we can use its add method. So we'll use our glist object, and we can call its add method, and we can just pass in a string to add a string into the list. So let's add in some roast beef, and then I'm just going to duplicate this line a couple of times, and let's change this one to add in some cheese, and then let's change the last one here to add in some honey wheat bread. Okay, so now we have a few items within our list. To access the items, we can use a get method and just pass in the index of the element that we want to retrieve. Let's try it out. Let's use system.out.println, and we'll use our glist object, call its get method, and we can pass in the index 0 to grab the first element within the list. Make sure to save your file, and let's run the program. And great, you can see that we get roast beef in the console. Now, a shortcut to grab just the first element in the list is to use the getFirst method instead. So we can change this, and we'll call the getFirst method. That's using camel case, so that has a capital F. We can save our file and run the program once more. And you can see we're still getting roast beef. Now we can duplicate this line, and there's a similar method for grabbing the last element, so we can use getLast. We'll save the file. And let's run this once more. And great, you can see that we're now getting honey wheat bread, which is the last element in our list. Now, the benefit of a linked list is that we can grow and shrink our list by adding or removing elements from anywhere within the list that we'd like. So let's start by adding new elements to the beginning and to the end of the list. So let's use our glist object, and we can call its addFirst method. And we can just pass in a string here. Let's add some lettuce. And this will add lettuce onto the front of our list. We can duplicate this line, and we can call a similar method called addLast, and let's add some fruit juice onto the end of our list. So if we save our file and let's run the program again, and this time when it prints out the first and last element of the list, you can see that we get lettuce, which was added to the front, and fruit juice, which was added on to the end. And now you can also just as easily remove elements from your list using the remove method. So let's try that out. Let's use our glist object. We can call its remove method, and we can pass in the index of the element that we'd like to remove. So we can pass in 0 to remove the first element from the list. Let's run our program, and you can see that it's now displaying roast beef again as the first item in the list has been removed, which was lettuce. Now there are a couple of shortcut methods for removing the first and last elements from a list. So you can just call the remove first method. Let's save this file and we'll run the program again. And you can see that we ended up with the same result with lettuce being removed. And you could also change this to use the remove last method as well to remove the last element from the list if you'd like. But I'll leave that up to you if you want to try it out. So those methods are great for adding and removing elements at the front and end of our list. But now let's see how we can work with elements which are located in the middle of our list. So when we create a linked list, our list object also has a method called List Iterator. And to use that method, we're going to need to be using a new class called the List Iterator, which allows us to move throughout our list in between the elements, kind of like a pointer. The iterator will point to a spot in between two elements within our list. We can then move that pointer forward or backward and insert or delete elements in the pointer's location. We'll need to make sure to import the List Iterator into our class. So I'm just going to close out the console here for a moment, and let's use the import keyword, and that's under the Java and util packages, and it's named List Iterator. That's with a capital L for list and a capital I for iterator. And now we need to create our iterator object. And where you create your iterator object within your code is very important. You must create the object after all of your list's add or remove method calls. And this goes for the add first, add last, or the remove first and remove last method calls as well. If you would create your iterator and then call your list's add or remove methods after it and then try to use that iterator, you're going to get an exception. So be very mindful of where you're creating your iterator object. So now before I create my list iterator object, I'm just going to clean up my code a little bit, and I'm going to get rid of everything except the list itself and the calls to the add method. So now we can go ahead and create our list iterator object, and just like our linked list, inside of angle brackets we put the type that we're going to be iterating over. So we have a list of strings, and I'm just going to give this a name of iter, short for iterator, and then we can use our glist object and call its list iterator method. And that will create our iterator object, which we'll be able to use to navigate between the elements of our list. So now that we've created our iterator, its pointer is located right at the front of the list. It's right before our first element, which is roast beef. Now to move the iterator around within our list, we have two methods, a next and a previous method. Next will move the pointer forward, and previous will move the pointer backwards. Now when you call the next or previous methods, in addition to moving the pointer, it also returns back the contents that was in the element that the pointer moved past. For example, our pointer is currently right in front of our list, right before our first element here of roast beef. So if we would call our iterator object's next method, the pointer is going to move to the next element. So it passes over roast beef, and it'll return roast beef back to us. And then now our pointer is sitting right before cheese, which is the next element in the list. So right after where we create our iterator object, let's create a variable to hold whatever's returned back when we call the next method. So our list is full of strings, so our variable needs to be of a string type, and I'm just going to give it the name of next, and then we can use our iterator object, and we'll call its next method. Now, before you attempt to move the pointer using either the next or previous methods, you should ensure that the pointer can actually move by checking if it has a next or previous position to move to. So our Iterator object gives us access to a hasNext and hasPrevious methods, which return true or false if you can move in those directions. So before we call the next method, let's ensure that we can actually move to the next element. Let's wrap an if statement around this, and we're going to check if the iterator has a next element to move to. So let's just grab this line of code here, and we'll cut it out, and we'll paste it here inside of our if statement. Now, if our if statement returns true, we know that we can successfully move to the next element, and we call our next method. Now let's use system.out.println, and let's print out its value to the console. We'll just pass in our next variable here. We'll save our file, and let's run the program. So you can see that it has indeed returned roast beef back to us. Since the pointer was at the very beginning of our list, it moved over roast beef, and it returned back the element that it passed over, which is roast beef. Now, you don't always have to store what the next method returns into a variable. Sometimes you just want to advance the pointer forward and then insert something into the pointer's position. So let's try that. I'm going to close out the console here. So instead of storing what the next method returns into a variable, let's just get rid of that, and we're just going to call the next method. And we know that's going to move the pointer from the start of the list past roast beef to right in front of cheese. So the pointer is currently sitting in between roast beef and cheese. Now we can use the iterator's add method to add a new element right into that position. So let's use our Iterator object. We'll call the add method, and let's add some lettuce in between roast beef and cheese. Now I'm just going to get rid of this line where we print out the next variable because we deleted the next variable. And we can verify that we did add lettuce to the list by using a for each loop. So outside of our if statement, let's create our for each loop. And we're going to be looping over each item in the glist as item. Now inside of our loop, we can use system.out.println, and we can print out each item from the list. I'm also just going to concatenate a string on here, which is just going to be a space. That way it separates each item in the list. And let's save our file, and let's run the program. And great, you can see that we have added lettuce right in between roast beef and cheese. Now, what if we wanted to delete cheese from our list? Now, to remove an element, we'll use our Iterator object's remove method. But there are some gotchas for using the iterator's remove method. You can only call the remove method after you've called either the next or previous methods. Otherwise, you'll get an error. So you can't call the add method and then call remove. You must use it after either next or previous. Let me give you an example. Let's close out the console real quick. And so right before our for each loop, let's try using our Iterator object and calling the remove method. Now, if you notice, the last method that we called was the add method. So if we save our file and run the program, and you can see that we get an illegal state exception because we called it after our add method. So remember, only call remove after a next or previous method call. I'm just going to close the console out. And now, so how the remove method works is that it's going to delete the element that the pointer passed over from the most recent next or previous method call. So if we want to delete cheese from our list, we just need to call the next method to move the pointer just past cheese, and then call remove to delete it. So currently, our pointer is right after lettuce from when we added lettuce into the list. So if we call the next method once, that's going to move the pointer over and past cheese, right in front of honey wheat bread. So let's do that right before where we call the remove method. Let's use our Iterator object, and we'll call the next method to advance the pointer. And now our remove method will work properly, and it'll delete cheese. Now we should probably call the hasNext method here to ensure that we can move forward one element, but I'm just going to skip it to keep this quick. So let's save the file, and let's run the program. And perfect, you can see that cheese has now been removed from our list. So remember, linked lists are helpful for efficiently adding and removing elements from the middle of a data structure. It's also really helpful for being able to traverse through your list by being able to move that iterator's position. Now, there are some additional methods for working with your linked list and the list iterator, like the previous method, which allows you to move backwards, and there's also a hasPrevious method to check if you can move backwards. So you should definitely check out the online documentation for more details. And for some additional practice, you might want to try moving the pointer around your list and adding and removing some elements. Next up, we're going to learn about a new data structure called stacks, but that's it for this video, and I'll see you in the next lesson.